Hello, dear students. Today we have Proposition 2 of Book 2. Book 2, Proposition 2. If a straight line be cut into any number of parts whatever, the square on the whole is equal to the sum of the rectangles contained by the whole and each of the segments. If a straight line be cut into any number of parts whatever, in this case just 2 to keep it simple, the square on the whole is equal to the rectangles contained by the whole and each of the segments. So in this case, we'd have 2 rectangles. Rectangle contained by this and this, plus the rectangle contained by this and this, okay? So it's going to be the same process. We're going to remember from our bag of knowledge, we know that a rectangle is contained by 2 straight lines in the right angle, okay? We cut from the greater line equal to the lesser. We can draw one line parallel to another. We can set up a perpendicular. We know that opposite sides of a parallelogram are equal, and given a line, we can set up a square. We've proven all that. We know we can do it. Okay? So the big deal here in this book is that given the line, let's say in this case a square, you know you have your square. You cannot make, given this line, you cannot make any other square. And given this line and this line, you cannot make any other rectangle. It has to be of a certain dimension, just by the definition of the lengths, okay? So let's do that. Let's make our chunks. Remember, that's a secret. You make the chunks in this book, make the chunks, show that the whole chunk is equal to the parts, each little chunk added together, and then you name each of the chunks with respect to the lines, okay? So let's make our square here. Draw this perpendicular to this, and cut from the greater, a line equal to the lesser. Let's say it's about that. So you just draw it indefinitely and then cut from the greater, a line equal to the lesser. We've shown we can do that. From this point, draw a line parallel to this other line, and from here, drop a line parallel to this. Okay? It's going to cut it necessarily at a certain point. Great. From this point, where the line is cut, let's drop a parallel line. Okay? And let's color in our chunks, our parts, just to make it more graphic for us, more easy. Okay? And this one. Okay? So, let's get cracking. We see that this is the square on this. So this big chunk is the square on this. Okay? And this big chunk is equal to these little chunks. So the square on the whole is equal to the rectangles contained by the little chunks. But this first little chunk is the rectangle contained by one segment and the uncut line, because this is equal to this, because this is a square. So this rectangle is the rectangle contained by the whole and this segment, and likewise this rectangle is the rectangle contained by the whole, because this is equal to this, because this is equal to this. Opposite sides of the parallelogram equal. This is one of the squares of the sides, by definition, equal to the other side. So this being equal to this is also equal to this. So this rectangle is the rectangle contained by this and the segment. But this line is equal to the uncut straight line. So this rectangle is equal to the uncut straight line plus the second segment. And since we showed that the big chunk is equal to the little chunks, and the big chunk is the square on the whole, and the left chunk is this rectangle contained by the whole and the left segment, and the right chunk is the rectangle contained by the whole and the right segment, it must be the case that given a straight line cut into any parts whatever, the square on the whole is equal to the rectangles, the sum of the rectangles contained by the whole and each of the segments. Quod erat demonstrandum. I think that's it. It's pretty self-explanatory. Therefore we have seen, I'll say it again, therefore we have seen that given a straight line, the square on the whole, given a straight line that's cut into any number of segments, the square on the whole will be equal to the sum of the segments contained by the whole, the rectangles of the sums of each of the segments and the whole. So one segment and the whole line. One segment and the whole line. One segment and the whole line. The square on the whole will be equal to the rectangles contained by the whole and each of the segments. Thank you very much. Bye-bye.